Welcome back students for the UGC series of lectures on laser applications. Now we are going to see something fantastic which is called laser in nuclear fusion process. In the introduction I have been telling that nuclear fusion is a dream project throughout the world because there are so many advantages. First thing, you have enormous amount of resources, first thing, because what you need for reaction purpose is a hydrogen. Hydrogen is available plenty in water. On the other hand, for nuclear fission process, you need uranium which is available hardly anywhere. Very little quantity of uranium alone is available on the surface of Earth because it is very heavy. That is the reason. Since hydrogen is easily available, so you do not have to ever worry about that the fuel for any kind of reaction will not be available. It will be there for another million years. That is first process. Second advantage, in a nuclear fusion process, there is no radioactivity at all. On the other hand, in nuclear fission process, there is radioactivity. In case there is a big explosion which happened in Chernobyl and then subsequently in some part of Japan also, few people died. Remember, it is very rare event. It is rarer than what you would expect in flight, in air flight. See, you know, thousands of flights are going up your sky, and thousands of cars are going on the surface, and thousands of trains are also going here and there. In all these travel, you have certain element of risk, of danger, loss of life. It is always there, accidents are possible. But what you should do, you must calculate what is the percentage or the probability of getting into fatal accident when I take this kind of venture, for example, in a flight or in a train or in a car. If you go back into what has happened so far, train travel is worse, difficult than your car. No, the other way. The worst accident comes in scooter, next comes in car, next comes in bus. What I mean is, bus travel is better than car travel is better than scooter travel, train travel is better than, safer than your bus travel, and flight travel is 10 times safer than your train travel also. This nuclear reactors are 10 times safer than any travel in flight. So, it is not the danger due to nuclear explosion people are worried. Now, coming back to this one, particularly in laser, particularly in nuclear fusion process, there is no radioactivity at all. So, you do not have to bury the nuclear waste into something somewhere, because what we are going to do is we are going to start with hydrogen, end up with the helium. That is all. Both are available, both are very common, already we are very familiar. So, it is not at all a problem. So, because of this only, people have been trying hectically for this one, for a big solution. Okay. Out of this, I already have told you, thermonuclear reaction or magnetohydrodynamic reaction is the most common, where you have a big bottle means it is not a regular bottle, it is a thick glass bottle in which you will have extremely good vacuum, then produce a discharge in hydrogen. That is all. In principle, that is all. In and around, you apply a very high magnetic field, so that the whole current, high current produced inside, you apply high voltage and high current, so that the ions are hitting each other. Not only they are high energy and they are plenty in number. If you have a high voltage, they will hitting each other very often, very strongly, If the current is high, you will have plenty of ions hitting with each other, and if you confine using a magnetic field, in a narrow passage the hitting will take place, and out of all these hitting, at least 1 or 2% of them will come together. The hydrogen isotopes will fuse together to produce helium. That is the thermonuclear magnetodynamic fusion process. It is one story which is also being tried in parallel. In laser, the story is different. You take heavy water, D2O, take a small pellet of this one, freeze it, take a small pellet of this one. It's about, it will be something like it's a grain of wheat, something like a grain of wheat, or something like a size of a pepper, that's all. You keep it isolated, and then you allow 12 high power, high current laser, high power laser of 10 power 15 watt existing only for a few picoseconds. That means it will be something like a lightning, 12 lightning hitting on the head of some tree. Imagine like that one, 12 lightning hitting the head of a tree. Imagine that one, what kind of damage it can do. This is what laser is going to do. They will put all the lasers together, focus it on the top of a very, very small pellet, produce intense heat for a short time. Because of the intense heat produced for a short time, the hydrogen isotopes will come together, produce helium, and that is what we call as a laser induced nuclear fusion process. It has been achieved, but what is the story? This is only part of the story. The story is something like this one. In all this process, people have tried variety of laser. The most common laser used was neodymium YAG laser. Such a laser which was done in USA, they are called Shiva's laser, because there were many Indian scientists, of course, many Indian scientists are there in US, in many parts of the world also. They are very respected, very popular. They have done extraordinary good contribution in science and technology. You must remember, in these days in software also Indians are doing extremely well. Anywhere people, if you say Indian, they immediately say, are you a software guy? That is all what they want. That is the way we have established. Now, coming back to this one, because of some fascination of some of these scientists, that kind of laser is called Shiva's laser, because Shiva is a god of destruction. He will produce enormous heat and enormous pressure, all this we know. Now, such a laser was a neodymium YAG laser, 12 of them. They were tried, but they were not able to do break even. Break even means, it is going back to it is a business word. If I put 10 million of dollar for a business, after 2 years, 3 years, 5 years, I should start getting at least 10 million or 12 million. Then only I would have earned 2 million as a profit for the efforts and the technology and the skill I have put in this business. Remember, I have put in my $10 million, my skill, my time. Not only I have taken a number of employees, experts. Only all these put together come into my field, and we all work together over years, and then we want to expect a benefit. This is what happened in Google also. Remember, Google, Facebook also. It took a lot of time for them to reach break even, which means after 5 years or 10 years, they reached the break even. After that, they started minting money. Facebook is the richest people. Google also very, very rich. Apple, these are the people who are high-tech people, and they are ruling the world, not only in technology, in financial control also, because it is a very, very big business, money earning business too. Now, coming back to this one. Now, can we do such a thing for laser? You put in so much money, so much energy for a Shiva's laser, and you must be able to get something more than what we have put in. This is called break even. When I said with the Shiva's laser, so far we have not reached the break even. That was the story. Then what happened? People started trying other types of laser. For example, they tried, instead of YAG laser, they tried excimer laser. They tried CO2 laser. You know, CO2 laser can be easily built, and it's a very efficient laser. First thing, CO2 laser is a very efficient laser. The efficiency means whatever is electrical power you put in, you should be able to get at least 10 to 20% of optical power. Such an efficient laser, such an efficiency is possible only with the two types of lasers, CO2 laser and diode laser. Neodymium laser efficiency is only 1%. Excimer laser efficiency is again 1 or 2%. That means, from the point of view of amount of energy that you put as an electrical energy, and out of amount of energy that you come out as an optical energy, only maybe 5% and 1% alone we are able to get as a optical power. That is the problem with the laser itself. So, instead of neodymium YAG laser, people went on for excimer laser and CO2 laser also. They were all trying many things. What is right now more or less successful? I would give this example. This 192 lasers, this is the recent achievement, not 12, 192 laser had been built in some place. I do not know the place. I can show you, they are not. Yes, this is the International Atomic Energy Agency sort of release. So, I must acknowledge for the photo. You can easily see so many lasers are focusing on a very, very small tiny target of D2O, and then and how they prepared laser I could explain here. This is the way it went on. So many lasers put together. First thing what happened is, when you put so much energy of laser, the first step is to do ablation. Ablation means peeling off the skin. Best example is, if we want to use potato, you put potato in hot water, then it is easy to peel off the top layer. In a similar fashion, the boundary layer of nucleus is peeled off first using this laser. Then all these laser beam put together will produce enormous heat, and because of the enormous heat, it will produce expansion. When the expansion comes, do not allow the expansion to come out. You have a barrier all around it. So, keep on building, 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 then all the heat wave that came up go back. That is called implosion. They can be focused such a way, all the big explosion. Imagine you have a bomb and you explode it. If you allow the bomb to explode, it will shatter the building, all the pieces will go out. Now, if we have a big spherical container and all the reaction bomb explodes, whatever goes, it will come back and focus inside at the focal point. This is what we did. This is called implosion. Because of the high temperature and high pressure, the two nuclei came together and they did really nuclear fusion. Now, before that one, you have to prepare the laser. How is the laser is prepared? I just give a quick explanation. You start with this is the laser energy. Whatever I said is explained here in a small circular or a spherical container. You have the pellet. Laser energy is focus, just look at these beams, laser energy is focused on the small pellet. Then you have the ablated material which come out. Then since you have the ablated material is prevented from escaping, it will go inward, and then all these put together produce a enormous compression, and that is how you get a thermonuclear burn. Thermonuclear reaction has taken place. The schematic of this one can be easily see this one. You start with the deuterium, 1 proton, 1 neutron. Another tritium, put them together. So, totally what do you have? You end up with 3 neutron, 2 proton. Now, during this process you allow 1 neutron to escape. Eventually you will end up with 2 neutron, 2 proton. The 2 neutron, 2 proton becomes a helium nuclei. We do not ever mention about electron at all. Electron is already gone, and once you have got a helium nuclei, this is what you mean by nuclear fusion process. We do not care about electron, because once the electron comes, so it can easily catch an electron and it becomes helium atom. Getting electron is nothing. Okay, 1 minute, let me explain how the whole thing is prepared. The laser, first we start with the pre-amplifier. The pre-amplifier has a neodymium YAG laser 1064 nanometer. This is a glass laser. It has an energy of the order of nanojoule coming from the master oscillator. That is the starting point. Then this is amplified more than billion times. So, it is essentially an oscillator amplifier. What is an oscillator? What is an amplifier? I have explained long ago. Oscillator will produce a particular frequency at a particular direction, at a particular energy and a particular phase. That is the source. Then it should be allowed to pass through a highly inverted amplifier medium. In this case, you have an oscillator, neodymium glass oscillator, and then you have a neodymium glass amplifier, laser amplifier, which will be very big, and using this you produce amplification a billion times. And then when you do this one, there will be a certain distortion in the spatial profile, divergence, everything. All these things have to be carefully adjusted, and after all this process, you will have 192 laser beams. Remember, you split them into 2 in many parts. The final conversion will be 4 million joule of infrared laser will be converted into 2 million joules of ultraviolet energy. I must recall you, bring back to your attention this already, this one word, one sentence already I have explained. In harmonic generation, if we have 1064 nanometer neodymium glass laser, is very similar to neodymium YAG laser. YAG is a host material where you have the host is a neodymium yttrium aluminum garnet. It is a crystal. Instead of a crystal yttrium aluminum garnet, if we have glass as a host material, this has an enormous temperature withstanding capability. It is very rugged. So, that is why people went on from YAG host to glass host. There again there are so many types of glasses. People have used just glass. This particular glass can be grown into a big, like this, it can be made into a big rod. It is very difficult to lift it. Such a big rod is possible, and you will have such a big amplifier. That is an advantage, and the heat dissipation is very good because of certain properties. From yttrium aluminum garnet, people went on to glass as a host material, but the lasing material is still the neodymium. Okay, now let us talk about neodymium glass laser. This particular neodymium glass laser also will produce a laser at 1064 nanometer. Then what do? You do third harmonic generation, which is from 4 million joules. Look at this one, it has been shown there, 4 million joules. It will be converted into ultraviolet laser of 355 nanometer with a conversion efficiency of 50%. I have just said this one. To do this experimentally, as an experimentalist, I have gone through all this exercise. It takes years to get 50% conversion efficiency from the fundamental to third harmonic, but there will be a group of people who are specializing in that line. There will be another group of people who will shape the pulse. There will be another group of scientists who will know how to take the heat out carefully. So, it is a very, very big team. All these put together, they have given their best. Eventually, such a laser was able to push the deuterium and tritium together to produce, look at the temperature. The lasers put together was able to produce a temperature of 3 million degrees Celsius. This did the ablation, this produced implosion also. Because of this one, you had a creating helium nuclei, or which is called the alpha particle, and releasing high energy neutrons and heat also. The high energy neutrons will become a source for heat also. After doing all this one, it was found out that we have been able to achieve what they call achieving fusion ignition has been reached. That means, once it is there, you must be able to have so much heat that the heat is getting back and do self sustaining, which is very important. Whatever we have said so far is just one process. One process will not produce power sufficient enough for supply to anywhere else. So, it should be self sustaining. All these stories took hundreds and thousands of people and millions of dollars investment, so that it becomes reasonably a profitable business. When I say profitable business, what it means is whatever energy that you get should be, whatever energy that you get out of this kind of exercise, out of technological exercise, should be greater than the energy that you put in. Now, the latest report was we were able to almost more or less we have reached the break even, and that I think, if I remember correctly, for this achievement, it went up to the Nobel Prize. I am not sure whether it won a Nobel Prize or not, but a year or two ago, it was hitting the headlines throughout the world that we are very close to break even in nuclear fusion reactors. I hope we will be able to make use of such energy for our future use, for heating our home, for lighting our home. When this is done, this will be a major human achievement. Thank you very much.